Welcome to this tutorial. I will show you how to connect a wiimote to Unreal Engine using MIDI data and then use it to rotate a 3D object. First of all, turn on the Bluetooth on your laptop. We are going to use a software called OSCulator that you can find for free online. This software will allow us to receive the data from Bluetooth and transform it to a MIDI type of data that we can use in Unreal. When you have it installed, you can power on your wiimote and then click on the top right parameters of the window, find Devices, then Wiimote. So to connect it, we're going to click on Pair a Wiimote and then press the red button at the back of it. Once it's connected, you can see its number appear in the list, and then the software will tell you that it's done. Also, you can observe the little blue light in the Wiimote. Once it's connected, click on the number, and then press all the buttons on the Wiimote to be able to see them detected and appear in the list. Don't forget to save your file somewhere. Once it's done, you will have to enter some parameter under the type and enter for each of the elements in the list MIDI notes. After that, you will observe that we have two different elements to enter under the value parameter. The first four are the senses, so we will have to get them as pitch bend, so that different and updated numbers can be interpreted from the movements. As for the buttons, you can give them each a different MIDI note, so that only one value is received per button. Once you're done with all that, don't forget to save, and then we will switch to Unreal. First of all, you will have to turn on the plugin MIDI device support. Have it enabled, and if it's not already, you will have to restart Unreal Engine. Once it's restarted, you can see that I created a basic empty level with nothing in it. You can create a new level in your project or use one that you already created. So here I'm placing a camera, and with this tutorial that I'm linking here, I made it a fixed camera later in the process. I'm also placing a sky sphere to have a nice background. So I used this really nice and complete Aiden Wilson tutorial to be able to connect a MIDI device to Unreal Engine. So basically this part is the same as he showed here. I will create a blueprint actor, which we will call MIDI control, so that all of the interaction from the MIDI data that we're going to do is issued from this MIDI control actor. Once it's created, you can place it in the scene, but be careful because you can only have one in one scene. So now double click on it to be able to access the event graph and delete these two nodes. So what we will build now is some elements to be able to find our OSCulator software. From Event Begin Play, we will search for Find All MIDI Device Info. Then for each loop. And connect the first option to the array. Then print string. and the array element of the for each loop to break MIDI device info. And we will link the device name. And in the parameters, change the duration so we can see data appear longer on screen. Once it's done, hit compile and save. And now appearing in blue, you can see the OSCulator out data, which is what interests us. Remember its placement in the list, because now we are going to change our elements in the event graph and ask for it to show us the MIDI device ID. When you hit play, you can see that the first one that matches the OSCulator out on my laptop is number 2. So please remember that number, because it's the ID number of the device. After that, we don't need any more these nodes, so you can unplug it from the event begin play. And from the event begin play, we will build something new to connect the different data that we're receiving from OSCulator. From event begin play, find create MIDI device input controller, and here we can put in device ID the ID number that we found. Mine is number 2. Then you should promote as a variable the return value and enter variable name, which will here be MIDI control 1. But you can call it whatever you want. Then from sets, please find bind event. Then we will take care of the buttons. Please find bind event to on MIDI node on, which will match the MIDI node data that we're receiving. And from here, which will take care of the pitch bend, find bind events to on MIDI pitch bend. So this is what we have now, and for each of them, you will have to take the red and create an event. And in that list, select create a matching event that you will call for the first one, MIDI button on. Then do the same for the MIDI pitch bend. Create an event. Then create a matching event and call it MIDI pitch bend on. Press compile and save so that you can see if there's any problems. What we are going to do now is trying to display on the data that we are receiving for each button when we hit play. the same way we found out which ID number we had. So from the MIDI button on, get a print string. I'm also increasing the duration of the data to 20 seconds. And from notes, because that's the kind of data we are receiving for buttons with OSCulator, find append. If you can't find something you're searching for in the list, just uncheck context sensitive. So we're getting that function and plugging it to the B rather than A, because the A is what will be displayed on screen before the data we are receiving. So we are going to write button just so we know what kind of data we are receiving. And then when it's done, the return value will be plugged to the print string one. When it's done, press compile and save, then hit play. And then now you can press any button on your wiimote and Unreal should be displaying numbers. The numbers by Unreal are different from the notes you're receiving from OSCulator, so you will have to press each button and write a list with the ID of each of the buttons so that you can use them as you want later. Once it's all done, we will do the same with the MIDI pitch bend. So basically, we are again gonna print string, changing the duration to 20 seconds again. And from the channel, we will search for append again. Still same as the first, I will plug it to B, and in A, I will write channel. This will display what sensor we are using. Then I will add 2 more pins to be able to connect pitch, and this is what will get the data as numbers. Once it's done, connect it to the print string and then compile and save. Hit play. And here you can see we are receiving a lot of data. And there's one problem. We cannot differentiate the different sensors because it's all in channel 1. So we will go back to OSCulator and in the list change the number of the channel for each of the different categories of sensors. Now when you go back to Unreal, you can see that it differentiates each different kind of categories. So now that it is perfectly connected, we will use some of that data to manipulate a 3D mesh into Unreal. So I'll show you how to change the rotation according to the sensors. I imported this simple 3D mesh here, which is an OBJ kind of object, whatever, and I simply called it object. Here I'm just placing it in front of my camera. At some point I added some skylight so that I can have some light shed on that object. Go back to the event graph of the MIDI control actor. I will unplug what showed us that data and put it and put it on the side for maybe later if it's needed again. And then we'll build some system that allows us to act on the rotation of the object using the wiimote. So for using the sensors, we will be interested in controlling the pitch bend. So from the pitch, find map range clamped. This will be able to adapt the data we are receiving. I just put the numbers that were used in the tutorial I saw, and it was perfect, so I left it that way. But it could be changed to increase or decrease sensitivity, I assume. Now we'll create a function that we will call rotate object. So Unreal will bring you to the inside of that function, and while having the little purple node selected, you will click on the plus into the inputs category to create a new input that I named pitch bend float. And from boolean to float, press compile to be sure that there's no problem. From the rotate object, find set actor rotation. And from the input pitch bend float, find once again the map range clamped, so that that node can translate the data. Here, for the in, I'm putting the data from before, and in the out range, sometimes when you connect a device to the laptop, the movement can be mirrored from the physical to the virtual, so I'm putting negative numbers to be able to correct that. Here, the rotation data is the same for each X, Y, and Z, but separate them to be able to access each different axis by right-clicking on New Rotation, and then split. So now you can plug the return value into each different ones and find the one that you like the most and works the better. You will also need to create a new variable, which we will call object var, and change it from boolean to actor. This will allow us to apply all that data to the 3D mesh. So I gave it the name object because that's what my 3D mesh is called. So now you can slide the variable into the event graph and select Get Object Variable. Here I made a mistake, so please leave it visible and turn on Instance Editable to be able to modify the 3D mesh that the data is applied to, even out of the event graph for later. Press compile and save. Now back into the event graph, we will plug that function in so that it works. Slide it in the middle and connect it to the others. Compile and save. Now back into the panel, make sure MIDI control is selected, and into object variable, select our 3D mesh. Don't forget to change the mobility from static to movable to be able to have the data applied when you hit play. Now hit play, and when you move your Wiimote, you will see that the objects can be rotated. You can later change the axis and edit all the numbers to find what kind of movement will match the better your object and what you want. I'm sorry I can't show it in a perfect way because this system requires quite some RAM. So here for example, I changed the axis and you can see that it rotates in a different way. Thank you for watching this video. I hope this will help you in some way, and have a great day.